Okay, the point of this example is to actually get through a factorization of a sum of cubes, and eventually we are going to attack a particular one, this sum of cubes of 27x cubed plus 1. But before we get into actually factoring this one in particular, it's a good idea to just note what the general factorization formula for a sum of cubes is, and it is this. But in order to kind of justify that that's the case, let me just multiply this out. So actually distribute the a from the binomial through all the terms in the trinomial here. That gets me an a cubed minus an a squared b and plus an ab squared. And now just do the same thing with the b from the binomial, distribute it through the trinomial, so that gets you a plus a squared b minus an ab squared, and finally plus a b cubed. Now, as you can see here, you've got some like terms that have been generated here. This minus a squared b will cancel out this plus a squared b. This plus ab squared cancels out this minus ab squared. So, in fact, as claimed, the only stuff that's left here is the a cubed that we started things off with, and the plus b cubed that we wrapped things up with. So, when you think of this thing going left to right, well, reading it left to right, it's basically a multiplication formula. It becomes the factorization formula that we can apply now if you just take this order and now reread it right to left. So if you start out reading it right to left, now the a cubed plus b cubed comes first and is equal now to exactly this factored format of a plus b times a squared minus ab plus b squared. So you can see with this thing that, well, first off, reversing that order does give you a factorization formula, and in fact it gives you a very nice pattern that you can use to actually attack any sum of cubes factorization. So first off, you can see this was a sum of cubes. It had a plus in between the two cube things over here. Well, that plus is exactly duplicated as the sign in the binomial part of the factorization, and then the two terms that are bookending that plus are exactly the things that were being perfectly cubed over here. To get a cubed, you cube a. To get b cubed, you cube b. The things that are being perfectly cubed are the two terms in the binomial. That's actually the key to a sum of cubes factorization. Once you got the binomial nailed down, you use the terms from the binomial to build up all the terms in the subsequent trinomial part. So you can see here, the trinomial leads off with a squared. That's the square of the first thing from the binomial. Then you have a minus. Well, that's the opposite sign to what you had in the binomial here. Then you've got the product of the two things in the binomial. Well, a and b were the two things from the binomial, so their product is ab. And then you add on with plus here the square of the second thing from the binomial. The second thing from the binomial was b, and you've got a b squared wrapping things up here. So once you've got your binomial nailed down here, this a plus b, the pattern always goes through a squared minus ab plus b squared. The square of the first thing from the binomial, opposite sign from the binomial, the product of the two things from the binomial, plus the square of the second thing from the binomial. So that's the format that you can actually apply now based on a pattern to factor down any sum of cubes, of which now this 27x cubed plus 1 is a particular example. So just to really confirm things here, you don't necessarily have to write this step out, but just for this first example, it's probably worthwhile just to note explicitly and write down explicitly what the things that are being perfectly cubed here actually are. We're going to need them to eventually start building up our binomial and subsequent trinomial factors. So 1's not so bad. The thing you perfectly cube to get 1 is 1. So that's all said and done. 27x cubed is only moderately more complex. The 27 you get by cubing 3. And the x cubed you get by cubing x. So 3x is the thing you perfectly cube to get 27x cubed. So now you know the things that are being perfectly cubed to get you the terms of this sum of cubes. They're 3x and 1. So when you kick in the pattern now, this sum of cubes is going to factor down as a binomial times a trinomial. And the binomial, well, we started out with a plus here, so there's a plus in the middle of the two terms of the binomial that are exactly those two things that are being perfectly cubed. The 3x for the first term and the 1 for the second. Well, now that we've got 3x plus 1 there, we can use that pattern that we noted up above to generate out our trinomial in this particular case. So the pattern is that the trinomial starts with the square of the first thing from the binomial. Well, the first thing from the binomial is 3x. The square of 3x then is 9x squared. So that leads things off. Then, opposite sign from the binomial. It was a plus here, so there's our minus. Then the product of the two things in the binomial. Well, the two things in the binomial are 3x and 1, so you multiply them together. 3x times 1 is just 3x, and then you wrap up by adding on, so a plus. The square of the last thing in the binomial. Well, the second term in the binomial here is 1, and 1 squared is 1. So there's the trinomial part of this factorization, 9x squared minus 3x plus 1. And you might wonder if this can factor down any further. Well, if you tried, in this case, you're not going to get any further factorization on this trinomial. This has a leading 9, a constant 1. 9 times 1 is 9. You're not going to find any factors of 9 that are somehow going to combine to minus 3 in the middle. So there's no trinomial factorization that could break this particular trinomial down any further. And in fact, this is no accident. In any sum of cubes factorization, and in fact in difference of cubes factorizations that we'll get to in later examples, the trinomial that comes out of either a sum or a difference of cubes factorization is never itself any further factorable over the real numbers. So once you've got that trinomial nailed down from your sum or difference of cubes factorization, you're done. There's no more factoring you can do. So there it is. Our final answer here is just 3x plus 1 times 9x squared minus 3x plus 1. There's our sum of cubes factorization.